Hello, I'm Michael Drow, and I'm a member of the Alliance for Parking Data Standards, an organization focused on improving the way various entities and industries share parking and mobility related data via a global data specification. Why is there a need for a data specification? Well, today in our connected world, we're sharing more and more data, and it's becoming a requirement to exist in this connected world. And through the sharing of data, entities are expending significant effort and cost to share just even the basic data between their own systems and their partners. What is causing all of this cost? A lot of it deals with entities using different terms and formats to store and send data. And it was determined that through standard specifications, it would make it easier to create, share, and integrate that data so that entities can start spending time on how to create value with the data rather than just sharing the data. The Alliance for Parking Data Standards was formed to drive this initiative to create a data specification. APDS was formed by three entities: the European Parking Association, the British Parking Association, and the International Parking and Mobility Institute in 2018. And since that time, we have been able to develop a robust specification that has involved many people. The objectives of APDS are fairly simple. We are a not-for-profit collaboration. Our goal is to collaborate with many external stakeholders, with entities within the parking industry, as well as outside the parking industry, including intelligent transportation system entities and organizations, automotive manufacturers, and mobility as a service providers as well. APDS does not have a revenue relationship to controlling data, nor will it create or aggregate any data on behalf of the industry. Our goal is to enable the faster and easier sharing of relevant parking and mobility data. We do this by developing common data definitions and associations for parking and mobility activities, with the goal to integrate parking more effectively within the parking industry, as well as with other standards that exist in other industries. As I already stated, the goal of APDS has been to be very collaborative, and as we've been very inclusive in the development of the specifications over the last 3 years. We are into our third and getting ready to start our fourth working groups, which has included both European, North American, and Asian entities. We've had over 500 organizations receive and comment on the various releases, and we have support and interest from parking entities or associations from around the globe. We also have strong sponsorship from within the parking industry, from both operators as well as the technology providers in the space in North America, Asia, and Europe. So now, let's talk about what is the APDS data specification. The specification is comprised of really 7 different data domains currently. And as the specification evolves, additional data domains will be defined and created. Today we have place, rate, occupancy, rights, sessions, observations, and quotes. And we also have guidelines on how to message the data through standard formats that are being used by entities throughout the globe to help people understand how to share that data in a common way. As we go into a little bit more detail on those 7 data domains, this chart shows you some of the detail that exists within each of the data domains. And then below this, there is even more detail. But for now, let's spend a little time talking about each of the 7 data domains in a little bit more detail. So we're going to start with the base data domains, which are place, rate, and rights. So first, let's talk about the place data domain. Place is all of the data associated with the physical location of a specific area that we are interested in describing. Our place data domain supports on-street and off-street parking, as well as non-parking activities as well, such as delivery zones, loading zones, no parking zones, etc. The data domain identifies areas and defines the usage of that area. As I said, whether it's a parking area, whether it's a transportation related area, or if there are operating restrictions limiting the type of use of that area. Through our place data domain, we associate addresses, geolocation, latitude, longitude information, as well as contact information. And place is a very important data domain within the data specification, as most other data elements refer back to place. Within the data domain of place includes a hierarchy, a way for us to describe in finer and finer details how a specific area is being used, all the way down to a space if necessary. Place is the prime area or prime data domain in this structure, and it is most recognized as a parking facility or an on-street parking area or a non-parking operating area, such as a delivery zone, a loading zone, etc. From place, an entity can further segment and define more details within their structure. Those are called hierarchy elements, and they allow you to build extra detail into a facility. An example would be a parking garage, which may be defined as a place. Within the parking garage, you may have 5 levels. Each of those levels could be a hierarchy element. Within a level, then, we can get down to an identified area. And an identified area is a homogeneous space that has the common operating characteristics or restrictions. It may be an EV charging area. It may be reserved parking area, as some examples. So let's go into a little bit more detail on each of those. Here is a sample data model for our place that shows the relationship to various other data elements in the place domain. This includes geolocation information, such as point location information, area location information. We have contacts, and then we have our common components, which we'll talk about a little bit more in detail in a couple more slides. The identified area data element, as we described, is where more detail can be applied to a place area that is of interest to the user. Identified areas support both vehicular entry and exits, as well as specific use areas. So what does that mean? We can define an identified area within the place data domain that describes the entry point for a parking facility or an entry point for a delivery area. And through that, we can identify the address, the operating times, when is that entry or exit area open? Are there operating restrictions to using that vehicular entry or exit? Are there limitations on weight, on size, and other things? This all allows us to define those requirements on how to enter or exit a specific area via that identified area. The second type is called a specific use area. And this again going back to our example of the parking garage with multiple levels. We may have a specific area on level 3, which is for EV charging. And with EV charging being identified as an identified area, we can then identify operating times, vehicle restrictions, other operating restrictions, and other relevant information associated to that area. And to further the example, directly next to the EV charging area on the level 3 of the parking structure may be a reserved parking area. And that identified area may have different operating restrictions and different operating times relevant to that specific identified area. So this goes into how we can build a place into subsegments that allow us to identify and share information relevant to various users of a place. That leads us into the space data element. The space data element is the lowest data element within our place data domain. A space data element is not a required field, but it is provided to allow an entity the ability to provide more information about specific spaces, whether it's in a parking facility or in a delivery or loading zone area, as an example. The space data domain allows us to define dimension requirements, as well as weight and limits, as well as other operating restrictions that may be relevant to that space. Obviously, each space can have different dimensions and different operating restrictions. And again, this is not a mandatory field. It is there for those entities that desire to provide this level of detail when sharing data. Finally, within the place data domain is the common component data element. This allows us to provide a lot of information that is common for multiple hierarchy elements within the place structure. And this includes, again, operating restrictions, characteristics of the structure or area that we're talking about. Is it covered? Is it open to the public? Does it have EV charging booth? Are there different operating types there, such as pay by license plate, pay and display operating methods, etc. All of this information is common to specific areas associated to the place domain. The next data domain that we'll talk about is rates. Within the data specification, APDS data specification, there are two components to rates: the rate table and rate eligibility. The data specification supports both fixed and variable-based pricing. In addition, the data specification supports the ability to define new pricing and have a date on when that new pricing should be scheduled to be active, as well as providing temporary overrides of existing pricing. An example being, I may have a daily parking rate, but on Saturday, I'm going to have a special event. We can schedule a temporary override of the rates for that event on Saturday that will then expire and revert back to the normal rate tables that exist. In addition, the rate table has the ability to define pricing for specific groups or vehicle types, which is defined as eligibility. So going into the detail, a rate table has an identification. It has an expiration date. It has a valid time for use, meaning this rate table is good from 10 a.m. to 3 p.m. on a daily basis. And it is a collection of rate lines and surcharges. So let's go into the rate line in a little bit more detail. A rate table contains one or more rate lines. And the rate lines would be most synonymous with the concept of a rate sign when you enter a parking structure. And you see the various rates for the various amounts of time that one may park or use the activity. Those would be considered rate lines. A rate line is a data element that defines how a fee is charged, and rate lines can be constructed with several different types of means. There can be a flat rate, where a single fee is paid regardless of the duration of activity. A flat rate tier, where a fee is paid in a step function of time or activity, such as day 1 is $10, day 2 is $15, etc. Or via an incrementing rate, where a fee is based on the actual usage based on a rate. As an example, €1 every 5 minutes would be an example of an incrementing rate. Rate lines also define appropriate taxes and surcharges. So if there are convenience fees associated with a rate table, I am selling mobile parking and there is a convenience fee of 30 cents, the rate lines can show the construction of that rate table with the charges on a per minute basis, and then also a rate line to identify what are the relevant surcharges to the overall transaction, such as a convenience fee or some other fees that may exist, plus the appropriate taxes to be charged. That is all defined in the rate table or the rate data domain. As we said, the other element of a rate data domain is eligibility. And eligibility defines who is allowed to access the rate. Eligibility can be defined by a vehicle characteristic. Am I a truck? Am I an electric vehicle? Am I a standard vehicle? It may be defined by a user association to a group. I am a tenant in a building, and therefore I have access to tenant rates. I am a resident of a community, therefore I have access to the resident rates in that community. Or maybe I'm a student at a university, and therefore I have access to certain student rates. And then the final eligibility is from previous activity. Maybe you are in a municipality that if you park in the morning, you are available to park in the afternoon at a related on-street parking space for a reduced fee. The rate table has the ability to identify those eligibility requirements and ensure a rate is not issued unless that rate eligibility terms are met. The next data element in the specification that we'll talk about is the right, also known as the kind of the credential data. A right is explicitly defines what the holder of the right is permitted to do and is the combination of a rate at a place or places during a specific time period for a specific customer or vehicle. The right defines the operating parameters for a customer or vehicle for parking or for related transportation activities such as deliveries, pickups, drop-offs, etc. The right domain also identifies the party that has granted the right, who has the ability to issue the right. So an example of a right is when you buy a monthly parking pass, you receive the authorization to park in a facility during specific times during a specific period. That is one example of a right. Another right is when you enter a parking structure, and if you go to the in-lane equipment and you pull a ticket, when you pull the ticket to park in that facility, that is an example of a right being granted to park in the facility. A final right would be performing a delivery service when you use in an on-street delivery area, a loading or unloading area. If an entity is managing access to those delivery zones, typically a permit has to be granted to use the loading or unloading zone. That would be an example of a right being issued. When we talk about right, there are several elements, sub-data elements to that right. And the most important concept to think about is the right specification. The right specification is the template that we use to describe a type of right that an entity is granting. So for a daily parker, or for daily parking in a parking structure, that right specification may be daily parking. There is a rate associated with it. There are eligibility requirements associated to it. In this case, for daily parking, it may be open to the public and you just cannot be a large truck. It's associated to a place. We identify the credentials that are valid to show that you have ownership of that right specification. It may be a license plate. It may be a pulled ticket. It may be an AVI tag or an RFID tag that is recognized as owning that right specification. We have available times to use the right specification. And then we also may have an inventory, also known as a pool, of right specifications. How many times can this right specification be issued? When a right specification is purchased or given to a specific user or vehicle, that is known as an assigned right. That right specification has been assigned to a specific person or vehicle. An assigned right can have a planned use, so that would be similar to a reservation. The planned use is this is an assigned right that is valid for use in 10 days from today. The assigned right also houses the financial transaction data associated with issuing that assigned right. Example being, if someone buys a monthly parking pass, they paid so many euros for that transaction. We have that documented to the assigned right. So that takes care of our base data. Now let's migrate into our operating transaction data. And these cover sessions, which may also be considered operating transactions, quotes, occupancy information, and observation. The one thing that we want to highlight is the Alliance has purposefully not used the word parking to consider the needs of operations to support mobility in these above transactions. Again, that goes to, while it does support parking activity, we also support mobility activity or curbside activity as well. So let's go into the various data domains included in this area. The first one would be session or transaction data. A session can be best described as defining a specific use of a right within a specific area. So that may be a parking event or an operating event, such as a loading or delivery zone. A session references the right that was issued, a place, a start time and an end time, a rate, and then if available, a space identifier. So example would be when we pull into a parking structure and take a ticket from the parking equipment, the issuance of that parking ticket is the start of a session. The timer has started, and when we exit the facility, the session will end and that session will be completed. An important element of a session is the concept of segments. And segments are sub-elements which allow us to better describe what's happening with a transaction. So an example of the use of a segment would be a parker enters a parking structure, but they enter and then they have the ability to go to a reserved area. And that reserved area requires a special access credential to enter the reserved area. Segment one would be the person entering the facility at the main entrance. Segment two would be when the person enters that reserved or controlled area with the special operating conditions. So segments allow us to break down the various activities of an operating transaction, but then relate them all together in a single session to see the linkage of those various activities and the various rights that have been assigned. The next data element is a quote. Quotes enable entities to share and confirm eligibility, availability, and price for a right specification at a place during a defined time period. A quote is a common term, and that same meaning is used within here. It allows two entities to share information and to request information to see if a parking is available or if a loading zone is available for use at a specific time at a specific price. Quotes can also be used not only to create new assigned rights, but also to check on the availability to extend an existing right. An example may be I'm parking at an airport on a reservation. I know my flight is going to be late. So a system would ask for a quote to extend that right specification. Is there availability for me to leave my vehicle in the airport parking lot for another 2 days? That information would be exchanged through two types of quote information. The first is the quote request. It is the party requesting to see if a right specification is available and my eligibility criteria meet that right specification. And then the response coming back from the facility owner would be the quote response. And the response provides the listing of those rights that are available for use or purchase. Typically, a quote response is going to have an expiration time. It may be you need to make this purchase within 2 minutes to complete that purchase, or it may be you have an unlimited amount of time to complete this purchase. The next data element in the specification is occupancy. Occupancy is broken into two types of data. The first is the supply. How many spaces or how much area is available in an operating area for parking or other uses. So this is typically a fixed amount, but that fixed amount may vary based on time. That time could vary because of construction. So normally I have an on-street parking area that has 100 spaces. There is construction going on, and for a 1-week period, 5 of those spaces will be taken out of service. Supply allows us to define the current supply as well as to communicate reductions in that supply on a scheduled basis. Demand is the current usage of the spaces or that area. Demand is determined and communicated by showing the level of precision in how that current usage is determined. Current usage can be determined by a sensor over the top of the space, which is sensing that space multiple times per second. In that case, we'll have a high level of precision and accuracy in that space. And the data domain allows us to communicate how that demand is being determined. Or the demand can be determined in a manual way with an operating manager walking the parking facility once an hour, twice a day, and counting the number of cars. That demand can still be documented, and we communicate the method of determination of that demand so that the users of the data can have an appreciation for the level of precision and currency of that calculation. And this is useful because when we compare supply to demand is when we have a view of utilization or predicted availability. And through the use of defining how demand is calculated, the user will be able to appreciate how accurate their expectation of utilization is. If an entity is using a sensor that senses the parking space multiple times per second, someone can be very confident that the current utilization is very accurate. However, if in the data being shared, the demand is shown to be a manual calculation that's done twice a day, and the last manual calculation was done 2 hours ago, someone then will have an appreciation that the data may not be as accurate as it was 2 hours ago. And that defines occupancy. Our final data domain is observation. And observations are data collections that show us that something has been sensed in the environment. And we want to communicate that because it's useful for managing or comparing two sessions and two writes to determine if there are enforcement issues or to just do calculations of usage. So an observation includes a date and time when an observation is made, a location where the observation is made, and if there is an association to a credential. So an example of an observation is a mobile license plate recognition unit driving down a street. Each license plate it reads is an observation. And with that observation, we have a license plate, the date and time, and where we found that location. That information can then be used and compared to assigned rights. And remember, an assigned right could be the right to park in an on-street space because you paid at a meter or you paid on a mobile app. That license plate is compared to those assigned rights, and if they match up, there is no enforcement issue. However, if we find an observation of a license plate and in our system there is no assigned right, we know there is a potential for an enforcement action to be started. So observations allow us to collect this data, share it, and then use it in other applications to determine enforcement needs, to determine occupancies, or other data collection needs. So that provides an overview of the 7 data domains currently in the data specification. Now let's talk about some of the applications of the specification that are in use around the globe today. The simplest one is the description of facilities or areas in mapping software or in lists. The data specification supports both on and off-street parking, as well as supporting non-parking activities, showing where a loading zone is, showing where a delivery zone is, showing where no parking zones exist. We have the ability to identify areas and usage. We can show where the entry to a parking structure is. We can show where the entry to a delivery zone is, and also share relevant operating restrictions and operating times as well associated to that. As I stated earlier, nearly all of the data in the data domain refers back to a place description. The next type of application is communicating rates. And this allows an entity to share their rate information to service providers as well as publishers of data who may publish that data to many other websites or users. It also allows an entity to describe the eligibility requirements to use rates. So a perfect example on the left is a city sharing their data through the service provider Parkopedia. That data still may be on a city's website, and the same information can be ensured to be the same because the data is coming from a common data structure and being published to those various entities. The next use case is around occupancy and availability. And again, using the combination of the supply, the demand, and observation data elements, one can identify the supply of spaces. We can communicate the use of spaces, how many spaces are being used today, how many spaces may be available in 3 hours if we can compare it to the planned uses of an assigned right, as well as sharing history of usage and how frequently that data was collected. Again, going from a manual data collection versus a sensor that may be sensing that space every couple minutes or every couple seconds. And through this data, we'll have a common definitions so that comparisons can be made between places and for usage. And then the final use case for our data specification is in curbside management. And this really brings in all of the various data domains and allows entities to communicate rules and permissions to use various areas, describing the type of uses that can be granted, delivery zone, parking zone, unloading zone, etc. Identify the authorized users of areas. So whether it's for a residential parking area, if it's a student parking area on a university campus, or if it's a delivery zone that requires approval by the municipality to do a delivery. We can define pricing and tariffs for various uses of areas, and it also enables a common enforcement method whereby the entities know what credentials to use to do enforcement, and the individuals understand what credentials are required to use a specific area. So that summarizes the various uses of the current data specification. If you're interested in learning more about the Alliance for Parking Data Standards and the data specifications, please visit the listed website. The data specification is currently in the process of being reviewed by ISO to become a ISO specification. We expect that to be completed sometime in 2021. So you'll also have access to the specifications through the ISO world as well. Thank you very much for your time. And we look forward to engaging with you on the standard.